Hey guys, it's Miss Smith, and in this video we are going to be going over the FRQ that we looked at yesterday based on how to interpret a graph. So let's get started. Okay, so the figure shows the graph of f prime, right? That's important. It's labeled as such. You might want to just kind of make a big note to self that that's f prime, not f. The derivative of a twice differentiable function f on a closed interval from 0 to 8. The graph of f prime has horizontal tangent lines at x equals 1, so here, x equals 3 here, and x equals 5 here. The areas of the regions between the graph of f prime and the x-axis are labeled in the figure. So we've got a 2 here, a 6 here, a 3 here, and a 7 here. And note that even though the area of this region from 4 to 6, even though the area is 3, that's because area is always positive. So if we were doing the integral from 4 to 6 of f prime, it would come out to be -3 because this is below the x-axis. So that's important. And then the function f is defined for all real numbers and satisfies that f of 8 equals 4. So there's an initial condition when we need it right there for f, because again, this is all f prime. Right, so this is the only thing we know about f right here, is that f of 8 equals 4. All right, so starting with part A. Find all values of x on the open interval from 0 to 8 for which the function f has a local minimum and justify your answer. Okay, so you kind of want to think sign charts here. For f to have a local minimum, if we think about what a minimum would look like on a sign chart, so if we had f, a minimum would be where f is switching from decreasing to increasing. And that means that f prime is going to be changing from negative to positive. So we want to look at this graph of f prime and say, well, where does this go from being negative to being positive? And that is happening right here at 6. Because this is f prime, right? So it's going from being negative below the x-axis here to being positive and above the x-axis here. So we just have to write a little explanation about that. Again, a sign chart is not accepted reasoning. It has to be a sentence. So x equals 6 is the only critical point at which f prime changes sign from negative to positive. Therefore, f has a local minimum of x equals 6. Of course, it does not have to match this wording verbatim. It can be worded however, but that is one point. Not just the answer, but also the justification with it. Some kind of worded explanation of that. But that's it for part A. All right, part B is a little more complicated because it's about an absolute. Determine the absolute minimum value of f on the closed interval from 0 to 8 and justify your answer. Okay. So we know from part A that we had a local minimum at 6, and that between 0 and 8, that was the only minimum, right? That's the only critical number that could possibly be a min. We've got a max here at 4, kind of for the opposite reasoning, right? Because it's going from positive to negative. And at 1, we have a critical number that is a dud because it goes from positive to positive. So we can say that f prime of 1 equals 0. That's true, but f prime does not change signs, which means that this is neither a max nor a min on the graph of f. Okay, obviously on the graph of f prime, it's a minimum, right? But we're talking about f. So sign changes at 4, but that's max. Sign changes at 6, that's a min because it's, again, that negative to positive that we talked about in part A. So 6 is the only candidate between 0 and 8, but we also want to be mindful of the endpoints at 0 and 8. Obviously, they're not going to be asking you the same question twice between part A and part B, right? It's not going to just be that simple as saying, it's 6, it's the only min, because you have to also check the endpoints. So from part A, we know it has to be either 6 or at an endpoint. So that means we need to think about what's happening at the endpoints at 0 and at 8. Okay, now they have written it out. This is like an official scoring guideline from a few years back. And they have written out kind of evaluating all of these. we would typically use a table here where we would figure out what we know about x and f of x. And we want to figure out, so we are testing x at the left endpoint 0, the critical number 6, and at the right endpoint 8. And again, we don't have to check the other critical numbers that are happening at 1 and 4. We can rule those out. If you do check it at 1 and 4, that's totally fine. We just know kind of automatically that that's not going to be it. Now, you will also notice that of the 3 points here on part B, the first one actually is only requiring us to check 0 and 6. We actually don't have to check the right endpoint 8. Well, why is that? Well, let's think about, again, the signs on f prime. Okay, from the endpoint at 0, f prime is positive, right? All that means is that the graph of f prime is above the x-axis. So what's happening is that we've got whatever endpoint's happening at x equals 0, and then the graph of f increases away from that somehow, right? That from 0, the graph is increasing because f prime is positive. So we know that that's going to be a min at the left endpoint at 0. But at x equals 8, we have to think backwards, right? That if we're at the right endpoint and f prime is positive up until the right endpoint, that means that just to the left of that endpoint, the graph was increasing to get up to where x equals 8, which means that 8 is actually a max because f prime is positive until you get to that endpoint, which means that f increased to get to that right endpoint. So on the left, if f prime is positive, that makes it a min because it's increasing away as you go left to right. But on the right endpoint, it's vice versa, right? Because f was increasing to get up to 8. So 8 is a max. It also can't be the absolute min. It doesn't hurt to check it, but we kind of already know that that's not going to be it. It's actually really easy to check f of 8 because they tell us at the stem of the problem that f of 8 is 4. But we already know that that's not going to be it. So we can cross that off. Okay, so how do we figure out f of 0 and f of 6? Well, as they're showing you over here, we have to use the initial condition and then integrate the function. Okay, so if all we know about f is that f of 8 equals 4, then we have to say, well, if I want to figure out f of 0, I have to say, well, for f of 0, I'm going to start with that known initial value of f of 8, and then I need to integrate f prime, right, because f would be the antiderivative of f prime, from 8 to 0, right? So remember that what's happening here is we're starting with the point we know. We know x equals 8, and then we're ending at the point that we need, which is 0. Okay, well, 8 to 0, that's backwards, right? So what do? They switch it around to make it go 0 to 8 and put a negative in front of it. That makes sense. And then, how do we get this, 0 to 8 of f prime? Well, that's where all these areas come in. Okay, so the integral from 0 to 8 of f prime is where I'm going to account for these areas, right? So that the integral from 0 to 8 of f prime of x dx is going to be, well, the 0 to 1 part is this 2. The 1 to 4 part is this 6. You see how easy this is? 4 to 6 is going to be negative 3, again, because this is below down here, so minus 3 for that. And then from 6 to 8 is 7. So we just take all that together. Right, so we've got 2 plus 6, which is 8, minus 3 is 5, plus 7 is 12. Okay, so coming back down here, that means that this is f of 8, which was 4, they gave us that, minus this integral, which is 12. So that comes out to be negative 8. So that is f of 0 at the left endpoint. And then f of 6, we do basically the same thing. We say, well, we have our initial condition at f of 8. We know that. We need to go from 8 to 6 because 6 is what we need. Okay, 8 to 6 is backwards. Flip it and change the sign to make it minus 6 to 8. And then we do the same thing, kind of come back up here, look at the graph. Okay, that if I need to figure out the integral from 6 to 8 of f prime of x dx, that's 7, right? 6 to 8, it's 7. Easy. So f of 8 minus 7, jumping back down here. So f of 8 minus 7, that's going to be 4 minus 7, so that's negative 3. And then doing the extreme value theorem, that's what this whole thing is on part B, right? That with the extreme value theorem, whichever value is less is going to be our absolute min, and that's happening at that left end point, which is ordered pair 0, negative 8. So the absolute minimum value, remember that it's the actual like y value itself. If they ask you where it happens, the answer would be 0. It happens at x equals 0, but the minimum value is the y value itself, so that is negative 8. And that is the absolute minimum value of f on the interval. All right, part C. Part C asks, on what open intervals contained in 0 to 8 is the graph of f both concave down and increasing, and explain your reasoning. Okay, so sign charts are probably going to be the easiest way to go for this. We can generate two different sign charts based on this graph. So concave down, first thing I would say is that means f double prime is going to be negative, right? If f is concave down, its second derivative is negative. And if f is increasing, then that means that I'm going to be looking for where the first derivative is positive. Okay, so let's actually start with that, with the first derivative being positive, because that's really easy since this is in fact an f prime graph, right? Okay, so if I just, let me come down here because I'm running out of room. Okay, so if I want a sign chart from 0 to 8, where is f prime positive, and what does that mean for f? Okay, so it's positive from 0 to 1. Right, it's positive here, because I'm not talking about where it's increasing or decreasing. I'm just talking about where it's positive right now. So from 0 to 1, it's positive. It's positive from 1 to 4. So I'll say 1 to 4, about the halfway point. 4 to 6 is negative. So I'll put a 6 in here, that's negative. And then 6 to 8, it's positive again. So that means that f is increasing, and then increasing, and then decreasing, and then increasing. Okay, right, so we wanted to know where f is concave down and increasing, so we've got our increasing bits so far. Next, we need to think about concavity, and that's a little bit trickier because we have an f prime graph, and we need to know something about that second derivative. Okay. So now we are going to change from looking at where this f prime graph is positive and negative to thinking about where it is increasing and decreasing. Okay? Because where this graph is decreasing, that means that its derivative is negative. And the derivative of this graph is f double prime. So where the graph is decreasing, f double prime will be negative, and that means that f will be concave down. And where f prime is increasing, that means f double prime will be positive, and if f double prime is positive, then f is concave up. Okay. So for now, let's just look at where f prime is increasing and decreasing. Okay, I'll make another little sign chart. I'm going to line it up right beneath the one I just did. And I'm going to look at where f prime is increasing and decreasing now. Okay, so I am decreasing from 0 to 1. So we'll come down here and say, okay, f prime is decreasing, right? This is not the same because earlier we were talking about F increasing, decreasing. This is F prime decreasing. Then F prime is increasing from 1 to 3. And that's why they mentioned this about a horizontal tangent line. It's telling you that this max is happening at 3 specifically, right? This min happened at 1. This max is happening at 3. So it is increasing from 1 to 3. So I'll just line that up here. Okay. And then the graph, F prime, is decreasing from 3 to 5, right? Decreasing from 3 to 5. So 3 to 5. And then the graph is increasing from 5 to 8. So we're not looking for the concavity of this graph at all because this is F prime. And its concavity would be related to its second derivative, which with regards to F would be the third derivative, and that's really just not what we are doing here at all. So we don't care about the concavity of this graph because this is already a derivative. We care where it's positive, negative. We care where it's increasing and decreasing. Okay, so back to our second sign chart here. So if F prime is decreasing, okay, that tells us that its derivative, the second derivative of F, is negative. And when the second derivative is negative, that tells us that F is concave down. And that's what we're looking for, right? We're trying to figure out where F is concave down, and also it was increasing. We got the increasing part from our first sign chart here. So F concave down is going to be wherever F prime was decreasing. So that's going to be from 0 to 1, it's concave down, and from 3 to 5, it's concave down. Okay, now finally, where is it concave down and increasing? Okay, so it is concave down, F is concave down, and F is increasing from 0 to 1. And then it's concave down from 3 to 5. It's increasing from 1 to 4. So from 3 to 4, it will be both. But at 4, it turns and starts decreasing, and we don't want the decreasing part, so we cut that off. So you are going to have to explain that with a sentence. It's like a lot of work with sign charts. I mean, you know, until you get the hang of it. But you still have to put it in a sentence to get the points here. So after all of that, the answer is worth a point this time. That's nice. It's because it took us a little more thinking to get here, obviously, than like on part 1, or part A rather. Part A was kind of quick with the sign chart. This was a bit more work, and then we had to compare two sign charts. So they are giving you a point for the answer and then a point for the explanation. Okay, so the answer, 0 to 1 to 3 to 4. Cool, that's what we got. But the explanation, okay, the graph of F is concave down and increasing on 0 to 1 to 3 to 4, and you can either write it as inequalities or interval notation is totally fine too, because F prime is decreasing and positive on these intervals. Now they put their reasoning here in terms of just F prime because that's what the graph was, and we could do that based on our sign charts, right? We could say, well, this is where F prime was positive and F prime was decreasing. Okay, but it also would be fine if you referenced F double prime, because we are talking about concavity, right? We are talking about concave down. So, you know, you could say that because F prime is positive and F double prime is negative, right? That would be fine too. So as long as you have a written, you know, worded explanation for both of those parts, right? Both the increasing part and the concave down part, and as long as it's technically correct, then you get the explanation point here for part C. All right, now that has only been 1 and 3 and 2. That's only 6 points so far. So there's 3 points still left here on this part D. The function g is defined by g of x equals f of x quantity cubed. If f of 3 is negative 5 over 2, find the slope of the line tangent of the graph of g at x equals 3. Okay, so they gave us a chain, right off the bat. This should scream chain rule at you, right? You've got an f of x if it's inside of a cube. Okay, that's kind of weird because f was the thing that this graph was, well, it was about the derivative of f, right? So that's weird. We've got an ordered pair on f now for this, and we want the slope of the line tangent of the graph of g. Okay, so slope of the line tangent means that we are trying to find g prime and evaluate it at x equals 3. Right? Find the slope of the line tangent. That means the derivative of g at 3. Okay, so first of all, based on this definition of g, we need to do the chain rule to get g prime of x in general, right? Because before we can figure out what it is at 3, we need to figure out g prime of x in general before we try to go plugging a 3 into it. All right, so first of all, they just want you to do the chain rule, okay? Now, they've written it here the way that most books do, which is backwards from what we do. We usually write it like this, where we do the derivative of the inside first, and then we would do the power rule on the outside. Same thing. That does not matter. So, derivative of the inside, right? Just do the chain rule. And look at that. You get 2 points just for knowing how the chain rule works on a really basic chain. There's no like crazy tricks here, right? Derivative of the inside is just f prime of x. Derivative of the outside, it's like u cubed, so 3u squared. Boom, bang, 2 points. Easy peasy. Okay, so we need to take a 3 and plug it into that. Okay, so if we're taking a 3 and plugging it into that, so that means that we're going to have this 3f of 3 squared part, which again, they put it in the front, it's whatever, and then an f prime of 3 part. Now, the f of 3, they gave you right here that is negative 5 over 2, right? They gave you that's going to be inside the square. For f prime of 3, we got to go back to the graph right quick, right? This is a graph of f prime. F prime of 3 is 4, right? Because again, that's not f, that's f prime, right? So that f prime of 3 is 4. So just knowing very basically that you just got to take that out of the graph, that's your f prime of 3. You got your f of 3 from what they gave you in part D. You do not have to simplify this. I wouldn't. I would leave it just like this. As soon as you have plugged in the numbers, if all that's left is arithmetic, you're done, folks. Y'all know that. But just getting that, right, that can count as your answer and get you that last 9th point. So that is it. And this is a real exam question from several years ago. This is from, well, 2013. So again, obviously we don't know exactly what the exam's gonna look like this year, but this is a typical 15-minute long question. So one of the exam questions this year will still be 15 minutes long, just like this one was, just like all the exams all the practice FRQs we've done in the past have been. All right, so thank you so much for watching, guys. Have a good one. Stay safe, be well.